At the end of the topic, you will be able to discuss sound energy, list down the sources of sound, describe the production of sound, define that vibrations produce sound, describe the propagation of sound through solids, liquids, and gases with activities. The sensation of hearing is sound. We hear sound all around us. Listen to the flying bees, birds, men, moving trucks, and many more. All produces sound.
Every day, every moment, we hear something from our surroundings. This sound is due to the vibration of bodies. Sound travels faster in solids than liquids and gases. If you place your ear on the railway track, you can feel the vibration of the motion of the train even if the train is 30 kilometers away from the railway station. This confirms that sound can travel through solids.
We can produce sound by various ways. Take a rubber band, stretch and hold one end of it with your left hand and the other end with your mouth. Now pluck it by right hand. What do you observe? Yes, the sound produced from the stretched rubber band is due to the front and back motion of the rubber band. This front and back motion is known as vibration. Let us see another example to produce sound. Place a blade at the edge of a table lightly and pluck it. You can observe that the vibrating blade produces sound. When you hammer a nail and when you vibrate a tuning fork, you can produce the sound. Production of sound stops as soon as the vibration of the object stops. By vibrating any object, we can produce sound, and also we can convert sound into vibrations or mechanical energy. Therefore, sound is a form of energy. Sound travels as wave. It needs a medium for propagation. Sound can travel through air, liquid, and solid. Now let us see an example to understand the propagation of sound in air. Take an electric bell. Place it in an air-filled glass jar. Switch on the electric bell. You can hear the ringing sound of electric bell. Then start removing the air present inside the glass jar by a vacuum pump. The ringing sound becomes feeble. If the air is fully removed, we cannot hear any sound even though the bell rings inside. From this, we understand that sound cannot propagate in vacuum, and it requires a medium for propagation. Now click the animation button to understand more. Sound also propagates through solids and liquids. Take a small bamboo pole. Ask your friend to scratch at one end. Keep the other end near your ear. Now you can hear the scratching sound. This proves that sound can travel in solids. Next, we will see the propagation of sound in liquid. Take a squeaking toy. Put it in a polythene cover. Tie the mouth of the cover tightly. Now keep this inside a bucket full of water. Now press the toy and keep your ear near the rim of the bucket. The sound first travels through the liquid and then passes through the solid. From this, we understand that sound also travels in liquids. At the end of the topic, you will be able to describe the sensation of hearing in human ear, identify audible and inaudible sounds. We can produce sound by various ways. Take a rubber band. Stretch and hold one end of it with your left hand and the other end with your mouth. Now, pluck it by right hand. What do you observe? Yes, the sound produced from the stretched rubber band is due to the front and back motion of the rubber band. This front and back motion is known as vibration. Let us see another example to produce sound. Place a blade at the edge of a table lightly and pluck it. You can observe that the vibrating blade produces sound. When you hammer a nail and when you vibrate a tuning fork, you can produce the sound. Production of sound stops as soon as the vibration of objects stop. By vibrating any object, we can produce sound, and also we can convert sound into vibrations or mechanical energy. Therefore, sound is a form of energy.
Sound is one of nature's gifts for communication. We express our feelings and emotions by speaking and making emotional sounds such as laugh, cry, and so on. When we speak, our vocal cord vibrates the air molecule. This vibration is transmitted as sound. All vibrating objects produce sound.
The ear consists of three distinct parts: the outer, middle, and inner ear. The outer ear. The outer ear consists of the pinna and the cavity called auditory canal, down which air vibrations travel to reach the tightly stretched membrane called the eardrum. These vibrations cause the eardrum to vibrate. The vibrations are then passed on to the middle ear. The middle ear consists of the inside of the eardrum and the three bones, the hammer, anvil, and stirrup, attached to it. These bones transmit the vibrations to the inner ear. The inner ear consists of the three semicircular canals and the cochlea. The cochlea is a coiled tube and is the real organ of hearing. Coiling down the middle of its whole length is the basilar membrane, which has a large number of hair cells across its width. These cells are connected by nerves to the brain. They transmit the vibrations as nerve impulses to the brain. The brain interprets the nerve impulses and produces the sensations which we call sound.
How do we hear the sound? Sound travels in air and reaches our ear. It then vibrates the eardrum. This vibration gets converted to nerve impulse and then it is sent to brain. This impulse gives the sensation of sound.
We have learnt about the transmission of sound in air. We can hear sound from different sources. Each sound is different due to its frequency. We can hear sound with the frequency ranging from 20 Hz and 20,000 Hz. This is the human audible range. If the frequency of the sound is more than the audible range, it is called ultrasound. This high-frequency sound cannot be heard by human beings. A bat produces ultrasound. We have learnt about transmission of sound and ultrasound. Now we are going to learn about infrasound. If the frequency of the sound is less than the audible range, that is 20 Hz, it is called infrasound. Some animals like elephants and whales produce infrasound which cannot be heard by human beings.
In this topic you have learnt, in human beings the sound is produced by the voice box or the larynx. The voice box has two vocal cords. They are stretched across the voice box in such a way that there is a narrow slit between them for the passage of air. When we speak, the lungs force air through the slit and the vocal cords vibrate, producing sound. The human audible range of frequency is between 20 Hz and 20,000 Hz. Sound of frequencies greater than 20,000 Hz is termed as ultrasound. Sound of frequencies lesser than 20 Hz is termed as ultrasound.
At the end of the topic, you will be able to define wavelength, frequency, and amplitude of the wave. State time period of wave.
In some bodies, the vibration is very small and it is not visible. The vibration in tuning fork is very small. When a vibrating tuning fork is brought near a cork ball, the ball is thrown away. From this experiment, we can trace the vibration in the tuning fork. The number of vibrations produced by an object in a second is the frequency of the vibration. You can hear the sound of the vibrating tuning fork when it is kept near your ears. Take a tuning fork. Beat it with a rubber hammer. As it starts to vibrate, the surrounding air molecules also start to vibrate. The air molecules move front and back about their mean position. When the prongs of tuning fork go away from each other, they push the surrounding layer of air molecules. Hence, air molecules are compressed. On the other hand, if the prongs move towards each other, they make an empty space in front of it. Then the air molecules move to fill the empty spot and hence less dense spot created. This is rarefaction. Every vibration of the tuning fork creates one compression and one rarefaction. This forms one full sound wave that propagates in air.
Now let us learn about the wavelength of the wave. Wavelength is the length of one complete wave. When the particle of the medium vibrates about their mean position, they produce crests and troughs. The distance between two successive crests or troughs is called wavelength. Its unit is meter. We have learnt about crest, trough, and wavelength. Next, we will learn about time period. Time period is the time taken by the wave to complete one full vibration. Time period is denoted by the letter T. Its unit is second. Next important term associated with wave is frequency. Frequency is the number of vibrations or oscillations made by the wave in 1 second. Frequency is the inverse of the time period. Its unit is hertz. Knowing the frequency and time period, let us now learn about the amplitude of the wave. It is the maximum displacement of the particles of the medium from the mean position. Amplitude is the height of the wave from the equilibrium position. In this topic, you have learnt wavelength is the distance between two consecutive crests or troughs of any particle in the wave. This represents one complete cycle of vibration. Its unit is meter. Time period is the time during which a particle of the medium completes one full vibration and is denoted by T. Its unit is second. Frequency is the number of vibrations or cycles made in 1 second. Frequency is the inverse of the time period. Its unit is hertz. Amplitude is the maximum displacement made by the particles from the mean position. Amplitude is the height of the wave from the equilibrium position.
Noise pollution. At the end of the topic, you will be able to discuss noise pollution. List down the various sources of noise pollution. Describe the prevention techniques of noise pollution. When you are caught in the traffic, you will hear the blowing horns and the engine sound of the vehicles. All these sounds are unpleasant and they cause irritation to our ears. These unpleasant sounds are noise. The sound produced by the aircraft and the sound from the crowd are of this kind. Noise prevails everywhere and is a sort of pollution and causes harmful effects when it crosses its safe limits. There are so many things which produce noise: aircrafts, trains, buses, motors, crackers, audience at a sports event, and people at marketplaces are sources of noise. Let us discuss the sound pollution and its hazards. Excessive noise in the surroundings may cause many health-related problems. Lack of sleep, hypertension, that is, high blood pressure, anxiety, and many more health disorders may be caused by noise pollution. A person who is exposed to a loud sound continuously may get temporary or even permanent impairment of hearing. Now, we will see the prevention techniques of noise pollution. We can control the sources of noise by the following methods. To protect ourselves from noise, we can use cotton balls in our ears. Noise-producing industries should be set up away from any residential area. Silencing devices must be installed in aircraft engines, transport vehicles, industrial machines, and home appliances. Use of automobile horns should be minimized. TV and music systems should be run at low volumes. Trees must be planted along the roads and around buildings to cut down on the sounds reaching the residents, thus reducing the harmful effects of noise pollution.
In this topic, you have learnt the unpleasant sound is noise. Unwanted sound from any source that causes discomfort of any kind is called noise pollution. Lack of sleep, high blood pressure, headache, and many more health disorders are caused by noise pollution. Trees must be planted along the roads and around buildings to reduce the harmful effects of noise pollution.